everybody. I'm Hayley Clowes, and I'm delighted to be joined by my colleague, Olivia. And today, we'd like to welcome you to our session on modelling our world with site suitability selection in ArcGIS Pro. An important part of analysis in the GIS field is the ability to locate where things are. But what if you want to know where something is expected to occur, or where something new should be? That is where suitability modelling comes in, finding the optimal site for your given scenario. For instance, planning a new bus route to support urban development projects, or looking at habitat areas at risk to support conservation initiatives. Site suitability, often known as multi-criterial analysis, is not new, but now we no longer have to build our models from scratch. Today, we'll be taking you through the 4 main steps that make up suitability modelling. Step 1 is defining the problem and identifying our criteria data, which will underpin your analysis and identify your suitable sites. The second step is to transform your data to a common suitability scale. The third step is to assign a weighting to each of the criteria to make them relative to one another and combine to create a suitability overlay. And lastly, it's important to put this suitability overlay into context and locate the most suitable sites for your scenario. Over the course of this session, we will look at using ModelBuilder in ArcGIS Pro to bring together multiple layers of data and identify sites that meet your criteria. Then I'll hand over to Liv, who will demonstrate how the Suitability Modeller tool in ArcGIS Pro makes this easier, and later discover how we can move our models to the web, putting the power of suitability modelling into the hands of more users with the help of ArcGIS Experience Builder. So let's take a look at this in the context of a real-world example. Did you know in the UK, since 2009, there has been an average of 30,000 wildfire incidents per year, with an average of 6,600 hectares of land burnt per annum? We will take a look at using suitability modelling to identify areas of greatest risk of wildfires, and then we can use this knowledge to inform our management and conservation strategies in the context of our fictional example. Firstly, we need to determine and prepare our criteria data. Our job is to identify some of the factors which impact the risk of wildfire. In our fictional model, we have considered fuel conditions, such as sources, like land cover, in this case illustrated by priority habitats. We have breaks in those sources, such as watercourses, and we've looked at factors which impact the speed of wildfire spread, such as slope gradient. Secondly, we've considered human activities, in this case, built-up areas, and using walking and cycling routes as a proxy for tourism. These areas can be at higher risk of wildfire due to the improper disposal of barbecues and cigarettes. And finally, for this example, we've considered meteorological factors, such as rainfall, drought, and temperature. Ultimately, the fundamental task here is to source the relevant geospatial data, of which many here are from the ArcGIS Living Atlas and our premium partner data offerings. Once our base criteria is defined, we then need to derive and transform our data to a common suitability scale. But often, our base data does not quite fit our criteria in its current state. So we can use Spatial Analyst tools to help us derive these. For example, creating elevation and slope data from our digital terrain models, or to derive a raster dataset from our vector inputs to illustrate proximity to a particular source, using the distance accumulation tool in the Spatial Analyst toolbox. Once all of our data is derived, we're on to step 2, where we can rescale and reclassify our data into a common suitability scale. In our model, our scale ranges from 1, areas least likely of wildfire, to 10, areas highly at risk of wildfire. And it's important to mention here that we've flipped our default symbology to display the most at risk areas in red. But don't fear if this data preparation is starting to sound overwhelming. We can string together much of this process with the help of ModelBuilder in ArcGIS Pro, which we'll come on to shortly. The next step in our workflow is to weight the criteria relative to one another and combine them to create a suitability overlay. This is where we can control the weight of each criteria as a percentage and make it more or less impactful on the overall analysis. For many years, this suitability overlay is where we would end our analysis, but this is no longer our end goal. What we're actually interested in is where we can focus our mitigation efforts, whether that be finding land parcels of a particular size or comparing a number of sites against one another. And it's this question which brings us on to the final step, to locate the areas to preserve. This step will identify, based upon our suitability map, which areas are most suitable or most at risk of wildfires. The good news is we can string together much of this suitability modeling process with the help of ModelBuilder in ArcGIS Pro. The challenge is you've got to know which tools to use and what sequence to put them in, especially when transforming your data to a common suitability scale. The rescale tool works by applying a selected transformation function to convert raster values into a shared suitability scale. But here's the catch. Understanding the nuances of each of the transformations requires either expertise or a keen memory from school maths class. Then, when making this choice, we are faced with the question, how will that transformation impact my suitability model? And what impact is that going to have on the overall analysis? Let's take our distance to water courses. We want the risk score to increase as we distance ourselves from the watercourse. Therefore, we may apply a linear transformation. But this is an iterative process, constantly refining and tweaking our parameters and exploring what effect a different transformation will have on our overall analysis. And then repeating this process for each of our individual criteria. This is only then exacerbated when adjusting our weighting criteria. And it's at these critical points within the workflow where the new Suitability Modeller tool comes in. Suitability Modeller is a dynamic and iterative process giving you immediate feedback and the unique ability to move back and forth between steps. This is where I'd like to hand you over to my colleague Olivia to demonstrate this exciting capability in ArcGIS Pro and how we can move this workflow to the web with ArcGIS Experience Builder.
Thank you, Hayley. Today we'll be focusing on suitability model in the Peak District National Park. Some of you may remember the Saddleworth Moor wildfire in 2018 that burnt 18 square kilometers of upland terrain, releasing nearly 37,000 tons of carbon from the peat-rich soils. The likelihood of severe wildfires like this is only likely to rise, as we're predicted to experience an increase in extreme fire weather days. Land and infrastructure owners must understand the wildfire risk to plan and implement wildfire resiliency measures effectively. In this demo, we will create an example wildfire risk model, identify areas that are at highest risk, and prioritize sites that could be most suitable for vegetation and fuel management. So let's jump straight into ArcGIS Pro. The Suitability Modeller can be opened from the Analysis tab when the Spatial Analyst extension license is available, or if you have an enterprise portal that has an image server configured for raster analytics. So let's open the Suitability Modeller pane. And as you can see, I've already added some of the data that Hayley kindly configured for us in ModelBuilder. So let's add the final layer, distance to tourist trails. The next step, as Hayley outlined, is to convert our criteria onto a common suitability score, from 1 being the lowest wildfire risk to 10 being the highest. So let's open the transformation pane for our distance to tourist trails layer. On the left-hand side of our transformation pane, we have a histogram providing insight into the distribution of suitability values in our final suitability map. The middle section allows us to select our transformation method, whether that be continuous or unique, depending on our data. And lastly, on the right-hand side, we have a transformation plot. This shows how our input criteria on the x-axis is converted to our suitability scale on the y-axis. When we make any changes to the transformation method, the plots on either side will be updated, providing us with immediate feedback. So as the distance to tourist trails layer is continuous, let's select the linear function and ensure that the invert function checkbox is ticked, so that the highest risk is assigned closest to tourist trails, as many wildfires are triggered by human actions. Let's go ahead and calculate this to see it reflected in the map. Here we are. Let's also take this opportunity to review our priority habitats layer. As this is categorical data, I've specified a one-to-one transformation using the habitat name field for this particular layer. From research, it's been found that an average of 37% of upland areas are burnt each year. So let's increase the score of these categories accordingly. This completes our criteria transformation. So let's review our current wildfire risk map. At the moment, all of our criteria is weighted equally in the model, but not all of these factors are equally important in determining wildfire risk. The Suitability Modeller allows us to change the weightings. So let's go ahead and edit our fictional model, weighting some layers comparatively higher than others, and review how this changes our overall model. You'll notice that when I calculate, the model runs through a sequence of calculations, iterating through the input criteria, which is what you can see flashing on the screen. And here we have it. You may also notice that I haven't had auto-calculate turned on during this demo, just for speed purposes. However, I would encourage you to use this functionality, as it will provide you with dynamic and immediate feedback whenever you edit your model. You could also use the Evaluate tab or open the Evaluate pane to determine the quality of your model by understanding the statistics and interactions between each of your criteria, their weightings, and also the transformations that you've applied. So let's reflect back to our goal of identifying and prioritizing areas for risk management. We can go ahead and open the Locate pane in the Suitability Modeller, and this will allow us to determine areas of highest wildfire risk, which also meet our spatial requirements. We want to apply prevention techniques to 10 different areas across a total area of 3 square kilometers. When we go ahead and run this, our output, the suitable locations, is symbolized by the average risk score, 10 being highest in the darkest blue. This allows us to prioritize areas which could be most suitable for vegetation and fuel management. But this isn't the end of the story. National fire and rescue frameworks must encourage land and infrastructure owners to include wildfire risk in their management plans. This will require planning and decision-making to be made in partnership with multiple stakeholders, working across local, landscape, and regional scales. So far, we have created a model in ArcGIS Pro, but we can also generate models in the web with ArcGIS Experience Builder, putting the power of suitability in the hands of more users. This provides us a tool rather than an output, which is essential to ensure it reaches and is shared with the necessary organizations in an accessible format. It is worth noting that to use your model in the Suitability Modeller widget, the input must be a weighted raster overlay service, which is not currently a direct export option from the workflow in ArcGIS Pro. To use your model, you must download the weighted raster overlay toolbox, create a weighted overlay mosaic, and then finally publish your model as dynamic hosted imagery layers. You will need an ArcGIS image for ArcGIS Online license to complete this. However, you'll be pleased to know that this will be included for creator user types and above, with the new licensing structure coming into effect this year. So once you've published your model, it's as simple as adding in the Suitability Modeller widget to your experience, and then referencing the service URL in the widget's configuration panel. So here we have it. A simple Experience Builder application allowing the end user to run their own site suitability analysis. So let's put ourselves in the shoes of one of a number of organizations that is responsible for the conservation of protected species in the Peak District National Park. We want to understand the wildfire risk in relation to species which could require further conservation measures. So let's select all of the factors that we'd like to include, whether that be one or all, and then we can go ahead and design our model, specifying the weightings of each of our criteria, and then going ahead and running the model to produce our wildfire risk map. But we can also explore the output by understanding the percentage breakdown of low, medium, and high risk for particular areas of interest. So let's go ahead and toggle on the species site assessment layer. Select this in our widget, and pick a particular feature that we would like to investigate further. This will create a pie chart, allowing us to understand the wildfire risk profile, which we could then go ahead and add to the site assessment report, or we could select multiple polygons or features and compare and contrast the wildfire risk profile between them. And here we are. But despite running this model through a web application, we can still use it dynamically, moving back and forth between steps, adjusting suitability scores as we go, to query wildfire risk from different perspectives. Many of the most endangered species in the Peak District National Park thrive in upland heathland areas, and a wildfire during breeding season could be detrimental to the health of the species population. So to find out areas which we could be at most concern, let's edit the suitability scores for our priority habitat layer. If we set any one of these scores to 0, the corresponding area will be removed entirely from the model, producing an output for just upland heathland areas, allowing us to have a more precise understanding of areas that could require further conservation measures. And here we are. And finally, we could then go and export our model to share with other stakeholders or include this snapshot in other web maps or applications. This just goes to show the power of site suitability modeling across ArcGIS.
Thank you, Liv. As we bring this session to a close, let's reflect on the insights that we've uncovered together. We've delved into the intricate worlds of data preparation, identifying key factors which impact our suitability score with the help of ModelBuilder. We've leveraged the powers of the new Suitability Modeller tool to assist us with the iterative process that is suitability modeling. And we've discovered how to share our models into Experience Builder, putting the power of suitability modeling into the hands of more users. Thank you for joining us on our journey of modeling our world with site suitability selection in ArcGIS Pro. And we invite you to leverage these capabilities to inform your management and planning strategies too. Thank you.